My name's Alex. I'm MacMan on Twitter. And as O'Reilly's conferences spell it, MacMan. They always spell my name wrong. But I have a confession to make. I like CoffeeScript. Last night I thought I had all these slides finished. And then I realized I'd written them all in CoffeeScript. And I was talking at a JavaScript conference. So I sort of rewrote them, weeping. Anyway, I like CoffeeScript, and I also like hardware. So I don't know about you, but I've always been slightly jealous of people who can manifest software in hardware. And so I set myself a resolution to basically learn more about building hardware. So I built this Arduino app. It's actually programmed with CoffeeScript, and it blinks whenever I receive a tweet. And every week I'm buying a new component. It's first like a GPS module, and then it's going to be an LCD screen, and then maybe in 10 years' time I'll have a rocket ship. But one thing I realized around hardware is there are some interesting design ideas. Redundancy. Everything in every component in hardware is designed around the idea of redundancy. So let's say you have a GPS module. It has a set API. You have no idea what goes on behind the scenes. You don't care. If it breaks, you can just replace it. If you want to upgrade it, you can just replace it. And this is quite an interesting idea, and it's called a hardware because if you have a component that's really integrated into your circuit and it fails, then it's really expensive to change it. And so this idea got me thinking that we should be applying this to software. And so this talk really isn't about Spine or about Backbone. It's about that file in your repository called mega.js, or maybe you call it base.js, or maybe you call it everything but the kitchen sink.js. It's basically that file where you put everything inside, and it basically overrides prototypes. It basically interacts with the rest of your application in weird and wonderful ways, and you can't remove it because it's so deeply ingrained into your application. And what I've been doing for the last 6 months at Twitter is basically refactoring the code, removing files that are called base.js, and separating everything up. So this talk is about structure, and it's about building large JavaScript apps. And one of the secrets to building large JavaScript apps is CommonJS modules. So what are they? Well, they're basically two things. They have two properties. You can expose properties to other modules, and you can require in other modules. So the syntax looks a bit like this. You have a module object, which is available inside every CommonJS module, with an exports property on it, and you can basically put anything on that exports property, and that'll be exposed. And then you can require in other modules. If you've used Node, it's exactly the same, or if you used Python, it's a similar idea. And I feel very strongly about this. I think everybody here should be using a CommonJS or AMD module system, because I think it's fundamental to building large JavaScript applications. So one of the ways I've been integrating CommonJS modules at Twitter is with this project called Sprockets CommonJS. Now, I don't know if many of you are familiar with Sprockets, but it's basically the library behind Rails' asset pipeline. It compiles the assets like CSS and JavaScript and concatenates them. Now, Sprockets CommonJS basically extends Sprockets with support for CommonJS. So basically, all you have to do is put .module in a name of a JavaScript file, and it'll automatically be wrapped up. So your JavaScript file might look like this, module.exports, and when it's served up to the client, it'll be wrapped up in this .require.define function. And I actually asked Jacob Thornton for help during this presentation, and one bit of advice he gave me was remove the semicolons and add some more spaces. Anyway, so you can basically, as soon as you include Sprockets CommonJS in your application, you can start requiring modules. And it's as simple as that. One of the problems is, though, you're back at the original problem when you're actually debugging the app, because Sprockets has compiled all your JavaScript into one big file. So if you are looking in Inspector, you can see this one big file. And Paul Irish touched on this actually in his talk. So I wrote this thing called Sprocket source URL, and this is just a stopgap until source maps are introduced properly, because it's really evil. Basically, all the scripts are avowed. Paul Irish didn't show this part, but basically, where the 3 dots are, your script goes, and then you append this like meta comment onto the end, and that basically tells Chrome, and actually Firefox has support for this as well. So before we have the meta comments and the eval, it looks like this, and then afterwards, like Chrome abstracts it all away and splits it up into multiple files. And the cool thing is you only have one script tag here. All you're doing is adding these meta comments, and everything else is abstracted away, and you can just do this in development. So I basically learn by setting myself projects and creating things, and one of those was an app called Styler, and I started building that a month ago, and I've been building that in the weekends and evenings. And you should, it's basically a WYSIWYG for designing web apps. It's early stages at the moment, but it's usable. You should all check it out, styloapp.com, and also a WebKit-based browser. And also I open sourced it, so it's all under the MIT license. And it's a CoffeeScript and Spine app. And here you can see I basically checked out every single commit that I made to this app, and then took a screenshot at every stage, so you can see it slowly being built up as I'm adding like more functionality to it. You can see the design slowly improving, hopefully, and more components being added to the inspector. So there's like 3 main components to Stylo. There's like the left-hand side bar, which I call the header, which is basically a way of adding new elements to the page. There's the main stage, which does all the like behaviors around like drag and drop and snapping and that sort of thing. And you've got this right-hand panel, which is basically the inspector, where you can basically add components, or all of these components and controllers down the right-hand side. Just change the styles of the elements in the main stage. And I love this quote by Justin Mayer. It's basically, the secret to building large apps is to never build large apps. It's to break your app into small pieces and then assemble those testable bite-sized pieces into your big application. And so this app may look complicated at first glances, but actually it's just composed of like a bunch of smaller controllers. And all these controllers know nothing about their parent controller. They're all abstract. So you see the color picker there. It knows nothing about the border inspector that it's in. All it knows is its own little job and its own little world. And all of these inspector panels on the right, I could remove and add to another application there. None of them are customized to this app or very integrated. And you can see the same with the file structure. I mean, people often forget to use like files and directories for some reason, but you can see like they're there. You should use them. You can see I've split up the app into like 3 main classes: element, inspector, and stage. And then what I've done is every element basically inherits from the main element. You've got like rectangles and lines in there, and then you've got the inspector, which has all the controllers down the right-hand side, and then the stage. And what I've done is I've split up every single behavior inside the stage. So let's say you have a clipboard for like doing copy and paste. That behavior is split up, and then the key bindings, that behavior is split up. And this means that we don't have like one massive stage file with every single behavior in there. Everything is nicely decoupled. So this is the secret to building larger JavaScript apps: is abstract components. Treat every component like it is a open source library, basically. So you like in Stylo, there's some open source libraries, like the color picker is actually open source separately, but everything is written as if it is an open source library. So it's abstract, it's not specific to the custom task, and it knows nothing about the rest of the app. So the controllers have to be decoupled. I have actually a number of rules around controllers. They have to be instantiated multiple times without adverse effects, and they work without being attached to the DOM. I mean, these rules work for spine controllers or backbone controllers, but they have a number of knock-on effects. If they can be instantiated multiple times without adverse effects, then it means that you can't change the global state on the page, because otherwise, the two instances are going to conflict with each other. Also, if they work without being attached to the DOM, then it means that they're very easily testable. It also means that you can't use CSS IDs with controllers, because you can only have one ID per page. You have to use CSS classes. So when I was building this app, I initially stored the data inside the DOM, and I don't know why I did that. But basically, I was serializing the CSS into elements, and then when I wanted to change a property, I would read that CSS, I would put it through this regex, and then I would change it into JavaScript objects, manipulate those objects, and then put it back in CSS. And that is like a terrible idea. Do not store data in the DOM. You should store, state in the DOM, or data. You should store it in the controllers. And I often believe, I believe that you should not store it in the models either, or the view. I often see people storing state in the models. I think you should just store data in the models, personally. So there's a number of conventions around the style sheets as well. Like I was saying, no IDs. I mean, this isn't no IDs full stop, but no IDs for controller elements. And you have separate style sheets for each controller, and you can see I've split every controller up into separate style sheets. Clear over dry. I much prefer repeating myself over code that's really unfathomable. And at the end of the day, it's just going to be gzipped and sent over to the client. So hopefully any repetition in the code will not actually make it over the network connection. Here's an example of a controller, CSS. Again, you can see it's all namespace with the class of the controller. So with the module communication, it's quite important to make sure that the modules are decoupled from each other. So what I say is to expose a simple abstract API like you were making an open source library. Use events. If any of you had PubSub, it's a similar idea. Private. A lot of people go into great lengths about making variables private in JavaScript, but I personally just put a private comment and have a very clear public API. It doesn't matter what's going on in the private API as long as the public API is good. PubSub events. In Spine, you can just basically trigger custom events and controllers, for example, in the color picker. And then in the parent controller, you can basically bind to those events. And the fact that they're events means that your app is not coupled together. So children should know about the parents. You should never be passing parent instances down to children. For example, let's say in Spine you have a stage which has a lot of elements. The elements don't actually know anything about the stage. They only know about their own little world, and then if they need to communicate with the stage, then they just bubble up events. So what I learned, use the tools. There's some awesome debugger in the browser. I think the WebKit Inspector is one of the best tools there is out there for any language, actually. You can pause on breakpoints. You can either click on the line number to add a breakpoint, or you can type breakpoint. And then you actually can access the context of the breakpoint. And another little useful feature a lot of people don't know about is that little icon there. It looks like a pause icon. If you click that twice, then it'll automatically add a breakpoint whenever there's an error. So that's a really useful tip because you don't have to actually add the breakpoint manually to find out why the error was caused. There's some great shortcuts in the inspector as well. If you click on an element in the inspector and then go to the console, if you type $0, then that'll be that element. That'll be a reference to that element. $0 to $4 is the last 4 elements you selected. Memory leaks, so I did a lot of optimizations with Stylo to try and find that, try and get rid of the memory leaks. In the inspector, you can see the memory usage, and you can see those dips is basically whenever the garbage collector kicks in. And if that line keeps going up, then you have a problem. And the way to fix this, one of the good ways of fixing this is with snapshots. And what you can do is you can go into profiles and you can take a heap snapshot. And then what you can do is add an element to the page or manipulate your app, take another heap snapshot, and then there's a little comparison button at the bottom of the page. And then you can do comparison between the snapshots. And you can see the difference in memory, and then hopefully you can work out here what should have been objects that should have been deleted that weren't. You can also see the painting of the browser. Basically, the idea is you want to reduce the amount of painting, because painting is expensive. And one of the ways to do this is with display none. For example, in the inspector, whenever you select an element, it's basically re-rendering the inspector, and it's doing a lot of re-rendering. So basically, I hide the inspector before I do rendering, so it only does one paint. So I hide it, do the rendering, and change the DOM, and then I show the inspector again, and then there's only one paint. Less DOM manipulation, basically the slowest thing you can do in JavaScript web apps is access the DOM. So if possible, you can basically use DOM fragments and manipulate the DOM when it's not attached to the tree and then reattach it later. Mouse movement handlers need to be fast. Now, one of the things that's more important than speed, I think, is perceived speed. And you definitely notice this when you're dragging something around. So the mouse move handlers need to be fast. I basically spent a lot of time in Stylo making sure that the function that was actually called inside the mouse move handler was as small as possible and did as less as possible. One of the things, one of the optimizations I had to make was whenever you select a new element in Spine, this right-hand inspector is re-rendered. And that's fine when you're just selecting one element, but when you're dragging a selection over 300 elements, it gets really slow. And so initially, I tried to use set timeout, but that actually wasn't that effective. I ended up using request animation frame. And now this is one of the things I usually associated with animation. Basically, if you aren't familiar with it, you can call request animation frame, you can give it a function, and it'll execute that function whenever it's convenient for the browser. By using request animation frame, I managed to speed up the rendering incredibly. So you can see here, basically, whenever the stage selection changes, we are basically calling this paint function, and this paint function says, if we're not already rendering, then call the render function inside a request animation frame. And then basically this gets called whenever it's convenient for the browser. This speeds up rendering so much. So you may have similar scenarios in your applications. Most importantly, I learned that advanced doesn't mean complicated. If you're using simple building blocks and you tackle large problems by splitting them up, then you can achieve anything you want to. Thank you very much. Are there any questions? Sure.
How exactly did you optimize your mouse move handlers?
So basically, you try and just do as little code. There's no code that's faster than no code. And just basically strip out the amount of function calls and that sort of thing. So the question is, can I explain a bit more about storing state in the controller? So for example, with Spine, the stage controller has an array of elements, which are the elements that are attached to the page. So basically, you just hold large objects which represent state inside your application inside the controllers. So that, yeah.
Isn't that in conflict with your concept of being able to reinstantiate controllers without adverse effects?
No, because that state is being stored inside that particular controller, not at a global level.
So one of the things you said was communicate with each individual small human controller via events. So one of the things that I've ran into when I build large apps is that you can end up being kind of event-bound. You couple basically to the events or to the API rather than having some kind of message flexibility. Did you run into that, or how do you solve that problem?
Yeah, I mean, so usually I don't use like a global message bus. I find just putting event handlers on instances much cleaner. Well, one thing I would say though is that you have to be really careful about cleaning up stuff and not leaving like event handlers around, because you can get a lot of memory problems that way. So one thing in Spine actually is this like release function, which gets called whenever a controller is like removed from the DOM, and you can basically unbind all the events that you bound to. So yeah, I prefer the API personally of just adding events onto the instances. Cool, thank you very much.